So, autonomous pivot. Let's start from just describing what happens in the United States in terms of irrigation. There are a lot of there are millions of acres of row crops that are farmed and irrigated in the U.S. Row crops could be corn, potatoes, soybean, and whatnot, alfalfa, cotton, and when they are irrigated, they are mostly irrigated by these irrigation pipes that are rotating in the field. Actually, you can see one behind me here.
Yep.
This is called an irrigation pivot. It's it's 1,200 feet or 400 meters of pipe that is rotating in the field. If you fly over the Midwest, you see these circles, hundreds and thousands of circles on the land, and these are actually the fields that are irrigated by this irrigation machine that we simply call them pivots. So what autonomous pivot is set to be is to actually revolutionize the irrigated row crop farming as it is done today. What we want to do is make the farming far more intelligent in a sense that we sense the data, we analyze it, and then we can have the optimal irrigation and then fertilizers and then chemicals prescriptions on those fields. So another thing that needs to be known is that through the water of these pipes, it is possible to put nutrients, and that's what farmers are doing, like nitrogen, and this is called fertigation. And it's also possible to put chemicals, and this is called chemigations, especially fungicides. And once we do that and we control and put the optimal irrigation, fertigation, and chemigations, then we can reduce the inputs or the water, the chemicals, the nutrient. We can reduce it significantly and even increase the yield. And when we do that, there are two benefits. First, the farmers gain more income because they spend less money. And second, in terms of sustainability and impact on the soil and on the health of the environment is tremendous, because we are not using as much water, we are not spending as much water as we are less contaminating the earth and the underground water with nutrients, and we are less contaminating the plants with chemicals. So to do all that, I'll jump directly to this slide here that just shows how the systems look like. It is basically a couple of sensors that are mounted on the pivots, moves with the pivot, and sense in different sensors. The number one, we want to solve the irrigation, and this is this upside down white pyramid shape. It is actually a radar, a ground penetrating radar. So it is non-invasive. Without touching the soil, we can estimate the level of moisture in the soil. The second one is a nutrient sensor that is working with active light. This is still under development. It's not in production yet, but it's expected to sense the level of chlorophyll to estimate the level of chlorophyll in the leaves themselves. The third one is a crop health that is starting to be in production this year. And it's simply detecting damage of any type, anomalies, pests, damage, and what's not on the crops themselves. There's also some other sensors like a rain bucket in the field, GPS, pressure sensor, temperature sensor. We add all that in the package. Generally, we want to collect as much information as possible in order to have the best insight on what's happening on that specific field. And all this information is collected, analyzed, and we'll see soon how, but eventually there is an app that is accessible to the farmer, to its agronomist, to whoever in that chain of command, and he can see all the information and the insights and the prescription that we give. We want to cover, or let's start and saying only that the main aspect that on the farmer's mind during the seasons are irrigation, fertilizers, and crop health. If we solve these three, we solve 90% of the problems that on the farmer's hand. And this, what we try to do here, we try to cover for irrigation, for nutrients, and for crop health. Let's talk a little bit about this slide, because if we understand this slide, we understand what autonomous pivot is about. So on the left-hand side, we have a couple of sensors that we've seen before, the soil moisture, the nutrient, and the crop health. All this data is uploaded to the cloud. In the cloud, we enrich this information with more data from the web, like soil type, like weather forecast, third-party data that we collaborate with. All this data is then fed and funneled into an AI engine that we develop in the cloud. And the output of that engine is alerts and prescriptions, irrigation prescriptions and fertigation prescriptions. These prescriptions are then going back to the pivots themselves, to the control panel of those pivots, and the pivot can perform the optimal plan. And this cycle repeats itself every 30 minutes. So in this sense, we sense, we analyze, and we act upon the optimal prescription. Currently, we provide irrigation prescription. In the future, we will also provide fertigation prescriptions. So this is what autonomous pivot is about. We are adding sensors and capabilities as we grow. And that's a technical part. We can see some screens of the app. Most interesting is the soil moisture in the soil, the recommended irrigation, and the specific screen for recommended prescription. I'll just show that we are growing significantly. We're growing exponentially, actually, in the years that we are active, in the last 5 years, since 2018, when we started with one system. Now we have close to 500 systems. And the cost of that is a SaaS, so it's $2,300 or $2,300 per system per pivot, per year, sorry. So it's basically per field per year. The farmers do not pay for any hardware, it's simply a service. We are looking for investors. We already raised a couple of $1 million, and we are mainly active in the US.